So solving problems where the object is on an incline. Now, you're going to be following the same 3 steps that you do for any force problem. You do free body diagram first, then you sum the forces, then you solve the algebra. Now there are 2 important tips, with the first tip being by far the more important one. So let me just start with the second tip, since it's real easy to talk about. If you have an object on an incline, make the direction of motion positive. So if this object is going down the incline, what you should say is down the incline is plus, up the incline is minus. Now what if the object is moving up the incline? Then say up the incline is plus, down the incline is minus. Whichever way the object moves, make that positive. Okay, life will be much simpler. Now, the first important tip for solving incline problems: tilt the x-y axis so that the x-axis is parallel to the incline. Or another way of saying that would be just make the incline the x-axis. Right? Now, why are we going to take the x-axis and tilt it? So typically the xy axis is like that, correct? Now why would we want to take the xy axis and tilt it? So I want you to all understand it. Don't just memorize. Don't be like, I don't know why, we just do. I want you to understand why we tilt the xy axis. And also I want you to understand that it's actually not even mandatory that you tilt the xy. You could solve the problem without tilting the xy axis. You could keep the xy just like that, and it's still solvable. However, it'd be a lot more difficult to keep the xy like that. So look, my first question is, say you have this object on the hill, and it's accelerating down the hill. So the acceleration is like this. The object is accelerating down the hill this way. And by the way, which way would the net force be? If the object on the hill is accelerating down the hill parallel to the surface, which way would the net force be? In the same direction. So at this point, you should know that acceleration and net force are always together. You're never going to have a situation where the acceleration's one way and the net force is another. Net force and acceleration are always together. So look, if this is our acceleration, is this acceleration perfectly x, perfectly y, or is it both? It's both. See, I'm going to stick it right there. So this acceleration, it's not x, it's not y, it's both. So if you kept the xy like this, and you go to sum the forces, you'd be like, all right, let's sum forces x, sum forces y. So every time you sum the forces, it's different. Every problem, it's a different summation of forces. So you'd have blah, bitty, blah, bitty, blah, but then when you're done summing the forces, what is it equal to? M. You couldn't just say MA here. Do you want to know what you'd have to do? You'd have to go, okay, let's break the A into x component, y component, right? And you have an angle like this. So I hope you're noticing this would be a big bummer. You'd be like M cosine theta A, right? You'd have to break the acceleration into components. And then you sum the forces in the y, you'd be like blah, bitty, blah, bitty, blah. It's different for every problem. But when you're done summing the forces, it's equal to M. You'd have to say sine theta A. Does that look like fun? So here's what I want you to do. What you're going to do is you're going to take your xy axis like this, and you're going to go tilt, 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 tilt. How far? There. Until what? Until the x-axis is parallel to the incline. Now, why are we doing this? Look, because now, which way is the object accelerating? Bam. There's the acceleration of the object. If this is our xy axis like that, this acceleration is now perfectly x. right? And then, by the way, what would be the y acceleration for this object? 0, right? Because this is the x, this is the x, this is the y, right? Is the object accelerating this way? No, there is no acceleration that way because the acceleration is perfectly x. All right, you guys getting it? Okay, so let's look at what a free body diagram would look like for an object on the incline. And then I'm going to show you what the sum of the forces looks like, and then we'll do a sample problem. Okay, so we take the xy, we tilt it, so let's do that again. Take this xy for an incline problem, just tilt it like that. Boom. Okay, now let's say this object, I'm going to give you a situation. I'll write it down here. Object accelerates down incline, friction is present. So what I want you to do, you try it first, because if I just show you, you're not going to really think about it. So I want you to do a free body diagram for this object. The object is accelerating down the incline, friction is present. So I'll give you 1 minute. Free body diagram, if you have the object going down the incline, friction is present, you have 3 forces in this situation. So the 3 forces, we have, number 1, we got gravity. Which way does gravity always act? Straight down like this. So we'll label this mg. That represents mg. Is this object on a surface? Yep. So there's a normal force. Normal force always points perpendicular to the surface. That's why we call it normal. Normal means perpendicular. And then lastly, if friction is present and the object is going down the incline, which way would friction be acting? Up the incline, because friction, the thing we know about friction, it's always opposite motion parallel to the surface. So friction goes back like this if the object's going down the incline. Hey, now in the homework set, you're going to have problems where the object is going up the incline. Which way would friction be if the object is moving up the incline? Then how would friction be? Friction would be pointing back like that. Friction is opposite motion parallel to the surface. Okay? So there's our friction. And friction is still equal to coefficient times normal force. All right, now, check this out. Is friction going to give you any troubles here? Nope. Friction's going to be easy. What makes friction very easy? It's perfectly x. You guys see this right here? Look, I'm going to pick up the x wire here. Ready? I'm going to pick this guy up. Just check it out, man. Friction. See that? Boom. Boom. See that? Friction is perfectly x. That's going to make life easy. Now, is normal force going to give you any trouble? No. Because why? Normal force is perfectly y. Does everybody see that? Now, what about mg? The force of gravity. Is mg going to give us a little bit of a headache? Yes, every time. For incline problems, just learn it now. Every incline problem, you're going to have to deal with mg. But it's much better than the alternative of not tilting the xy. So look, mg, I'm going to put it right there. Notice that mg is part x and part y. So what I'm going to do is I'm going to show the components of mg. So I'm going to get a red pen. Okay, so right here, this represents the y component of mg. This represents the x component of mg. So I'm going to label this guy mg y component, and then I'm going to label this mg x component. Okay. The real quick thing I want to point out, what force pushes the block down the incline? And I know it's gravity, but be more specific. It is gravity, but be more specific than gravity. What force pushes the block down the incline? Ooh, yeah, it is net force. But I think the better answer is mgx. Do you guys see this? What is mgx doing? The x component of mg is pushing the block down the incline. Now, what would the net force be? The net force would be this minus this. That's the net force. Okay, so back to this. To break apart mg, we're going to need an angle, right? When you break apart vectors, remember like when we did two-dimensional motion, you know, you break, like the ball is kicked at an angle, so you use sine and cosine. We're doing the exact same thing here, but we need an angle. We're going to need this angle right here. Can anybody figure out what that angle has to be? You're using like your geometry skills? It's got to be 40. If this incline right here, if it's a 40-degree incline, this must be 40 as well. Why? Let me show you why. Look. So bring this over like this. Bring mg down. That makes a 90 right there. So if this is 40, if that's 40, then what must this angle be? 50, right? And then that means this must be 40 because the two have to add up to 90. It's a little geometry problem. So you can prove it. You can prove it to yourself, or when you're doing these problems, you could just remember that the angle of the incline will always be the angle inside here when you're breaking apart mg. Okay, 40 degrees. All right, so we're going to sum the forces. Oh, let me put down sign conventions too. Hey, sign conventions. This object is going down the hill, so we're going to say down is plus, up is minus, like that, plus, minus. So we got sign conventions, we got x, y. Let's sum the forces, and then after we do this, we're going to try a sample problem. All right, so summing the forces. All right, summing forces. We're almost done with this lecture. How many forces are in the x direction? And remember, the x direction is this way. This is the x direction here. How many forces are in the x? 1 mgx and friction. We have 2 forces in the x direction. Now, which one's going to be plus and which one's going to be minus? Mgx is going to be plus, friction is going to be minus, because friction points up the hill, mgx points down the hill. Now, what you don't want to do, look, what you do not want to do, and I've seen many, many, many kids do this, they're like this. All right, let's sum the forces x. So we got mgx. Awesome. Is that going to help you at all if you write mgx? I mean, I guess technically it's right, but you're not going to be able to do anything with that. What you got to be able to do is put mgx in terms of mg, right? Should I say that again? Put mgx in terms of mg using trig, right? So look, notice we have a 90 degree right here. That's a 90-degree triangle. What's the hypotenuse of this triangle? mg. So what would mgx be? Mgx is going to be sine 40 mg. What's mgy going to be? Cosine 40 mg. It's just trig. All that is trig. So summing forces in the x, we're going to have positive sine 40 mg. Why did I say that was positive? Because it which way does mgx point? Down the hill. That's positive. Okay. Minus friction, which I guess you could put just mu Fn. The equation for friction is mu Fn. We'll just say minus friction. Okay. What did I just do right here? I just summed the forces. What's the sum of the forces equal to? ma, where that would be an x acceleration, where x is the incline. Okay? Now, how many forces are in the y direction? We have 1, 2. There are 2 y forces. And remember, which way is the y direction? Y direction is like that, perpendicular to the incline. Okay? So, sum of the forces in the y, you're going to go normal force minus cosine 40 mg, right? What's cosine 40 mg? That's mgy. Equals ma, where that's a y acceleration. Now I'm going to tell you, one of these a's is 0. Which of those a's will be 0? The y acceleration, because remember, which way is this block accelerating? It's accelerating this way, which is the x, but not this way. So what we can do is we can take the y acceleration and set it equal to 0. All right, at this point in the problem, the hard part's done. The rest of it's algebra. That's the end of my lecture. Any questions on this? Okay, so now we're going to try a problem.